This is Stats, Chapter 1, Section 4. So the last bit is talking about the actual studies themselves, studies/experiments. So you're either doing a study or you're doing an experiment, basically. So if you're not modifying, you are doing a study, okay? Not an experiment. It's one or the other. So basically, there's no treatment. You're not doing anything to them, right? So if I'm just, clocking high school kids, seeing how fast they run around the track, that's a study. I'm just timing them, right? But if I kick them in the shins, 4 or 5 of them to see if it actually slows them down, I'm giving them a treatment or a modifier, and that's an experiment, basically, right? So there's only 3 types of studies, right? There's, well, as far as the overall arching, as far as time period, there's the cross-sectional, which is when you do it over one point in time, like a cross-section of a tree, okay? There is the retrospective, which retro in the past, okay? That's data from the past. And pro, which is the future, is when you do a study from for the future, basically. Okay, and we're going to conduct a study, right? We haven't done it yet, which is also called a cohort, by the way. So if you're in medical or nursing, you'll see the word cohort all the time. That means the same thing. They're just not using this terminology. Again, it's like elevator versus lift. I'm saying, soda versus pop, same idea. Okay, I made you a little diagram right there. Okay, so you record, so using city records, right? So you go into city records, anybody can do this, or town records if you're in the town, and you determine birth rates of women in your town over the last century. Well, that's something in the past. That's a retrospective study, correct? Versus, you give a questionnaire about salary compensation to all faculty that they fill out and return that day. Well, again, that's a cross-section. That's a cross-sectional study. Because, in the past, they made less, and in the future, they made more. Or at least one would think, right? So the question is, what are we right now? It's a cross-sectional. It's not over a large period of time, right? Okay, and to determine if the number of terminal cases of infectious diseases is changing or staying the same with modern medicine advances, you collect data of deaths for the next 20 years to see trends. Well, that's what's going to happen in the future. So that's obviously a prospective study to see if it's going to go 1-to-1, basically. Okay? Okay. So if you're not a study, those ones are easy. You just collect the data and you show it, basically. It's an experiment. But in order to be an experiment, you need a treatment. Right? So that's kicking them in the shins, giving them a drug, taking something away from them, whatever the case may be. So you have to do that to the experimental units, right? The experimental units are the things or people with whom the experiment is being performed on, right? So an experiment is basically when you look at the treatment's effects on the units, right? So what did that treatment do? That's the goal. So you have the people or things that were not treated and people or things that were treated, basically. And it comes down to variables, basically, which are either qualitative or quantitative, right? And again, that's important to know for which test to use later on in the course, and especially in Stats 2. So if it's qualitative, it's nominal and ordinal data. If it's quantitative, it's, discrete or continuous, and at that point, is it the other types, right? If you remember what those types were, right? It's the interval and ratio, correct? Right? Whether it has a natural zero is what it basically comes down to. Okay, so what you saw in probably high school algebra is independent and dependent variables. Okay, but we use explanatory and response variables, which actually fit a little bit better because it has to do with the treatment. So the treatment is applied to the explanatory variable, and we want to see the results of the treatment in the response, basically, right? So this variable is explaining this other variable, which is the outcome or the response, basically. Okay, and you may or may not have one or more extraneous variables, right? Extraneous variable or extraneous variables. These could happen. These are third-party variables, which we talked about earlier with confounding, basically, right? So it's an extraneous variable is either lurking or it's confounding, right? So it's lurking if you did not consider it. If it was considered, it becomes confounding. So a lurking becomes confounding if you actually account for it. So let's say you're doing drug effects, and you don't know if it affects gender or not. So lurking is that somehow the muscle mass of men change it, or women's different biology, organs change the drug. You know what I'm saying? That's a lurking thing. But if you confound it, which means you separated them into groups by gender, you confounded it. So can I get rid of their gender? No, I can't get rid of that. You know what I'm saying? There's nothing I can do. It's confounded in there, but I can account for it, right? So it doesn't. So I know basically, what's happening as far as explanatory response. Also, it could be like your weight, your age, anything like that. You know what I'm saying? Anything is I can't remove your age from you, because maybe when you get older, you can, not take it as well, or maybe you can take it better versus being a child. Okay. All right. So you hope that there's causation, basically. That's the goal. But perhaps this other variable is, throwing the whole thing off, which is why we want to confound if we can. Okay. So let's look at here. So there we go. Perfect. All right. So let's see here. Let's read this. So you try to determine if a new diabetes drug works. You inject various amounts of the drug in milliliters into healthy people and people with diabetes. So that means you're going to have a few different groups. You're going to have people with diabetes with the drug, and without diabetes with the drug, basically. Healthy people and diabetics are injected with placebo instead of the drug. So you might get like a water pill or something, or saline or whatever. So that means you have four groups. You have people with diabetes with saline, people with diabetes with the drug, people who don't have diabetes with the drug, and people who don't have diabetes getting this. There's four groups basically. So you have basically two control groups and two experimental groups. So either way, the experimental unit is people with and without diabetes, correct? And the treatment basically is the new diabetic drug or the placebo. You're getting one or the other basically. You're not getting both. It's not and, right? And you want to see between those four groups what happens, because you need to figure out, what happens normally with this drug to people. Does it actually change their blood sugar or not? Okay, so your explanatory is the thing you're treating, right? So you're treating the amount of milliliters of the drug in the blood, right? The point of the study is not the amount of drug in your blood. That's not the point of the study, right? The point of the study is the amount of sugar in your blood, which is not a measure of the amount of medication. Because maybe the medication increasing or decreasing does something, maybe it doesn't. We don't know that. So this is your X and Y, basically. So I'm increasing this. That's what the treatment's going on to, correct? And this is the outcome variable, the response variable. Okay. Is there any confounding or lurking variables, basically? Okay. Well, you monitor their blood sugar levels, determine outcomes of people. The overweight show different results. So weight of the people in the study are a lurking variable. Well, why is that? Well, I didn't separate them out or do anything about the weight. I'm just finding that there is a problem. So I don't know, basically. So weight of the people in the study, that should be is a lurking variable, right? Okay. So if I somehow account for it by putting obese people in one group and non-obese in the other, or maybe three groups, by BMI, then I can account for it, but I didn't do that apparently. So that's a problem. Okay. All right, treatment group. So we talked about that a little before, because we had four groups before. So we had people getting treated who didn't have diabetes, and people getting treated who did have diabetes, and we had the control group, which is the people who got the placebo before, right? So we had people with diabetes and without diabetes that were the control group, basically. So if you do receive the treatment, you're a treatment group. If you do not receive the treatment, you're the control group, right? Oh, so the placebo effect is a problem. So some of those people got placebo. So the people without diabetes and diabetes, some of them got the placebo. If they report false symptoms, it's not that something happened. Something did not happen. They just think something happened. They're reporting false symptoms, right? Because placebo effect is thinking something happened or reporting it. And Hawthorne effect is when you do something. Okay, so that's when you change your behavior. If you change your behavior, okay, then that's a Hawthorne effect. If it changes the outcomes of the study, and that's bad. You don't want to do that. I mean, either one of these is bad. There's not much you can do about this other than hope they don't do that. But placebo, you fight this in two different ways. You either do a blind or double-blind study, basically, which is a strategy called blinding. Okay? So, in a blind study, the subjects do not know they're being treated or not, if they got the placebo or not. Okay? Versus, in a double blind, the subjects still don't know. Okay? But also, the researchers do not know. So a lot of the books say doctor, but doctors aren't always the ones doing the research. So both don't know. So if you're doing any medical stuff, this is the gold standards. Anything that's medical has to be this, basically. So you'll see that come up quite a bit in all the medical stuff in nursing. Okay. So let's look at a few studies here. So prior to being treated, subjects in a study report their energy levels over 6 months. Over the next 6 months, the same subjects take over-the-counter vitamins of their choice. The subjects are not normally vitamin consumers. The subjects report on their energy levels over the 6 months under the use of vitamins. Some subjects take up walking and sports hobbies in the belief they have more energy from vitamins. The researchers compare results to determine if there are any changes in energy levels by the vitamin usage. Okay, well, the control group is the people 6 months prior to study not on vitamins, right? And here is unique because last time with diabetes it was different people, right? For two different groups. Here it is the same subjects again used twice, which is fine. It doesn't matter whether it's the same people or not in most cases. Sometimes it does. So the diabetic study was different people, right? In this case, it's the same people, right? So we had two control groups and two treatment groups in the diabetes study, and here we have one control group and one treatment group, which happen to be the same people. Okay, the placebo, well, we're just giving them vitamins. They're taking vitamins. There's no placebo here. None. Doesn't have to be. And the blinding method, well, they picked it out. They know what they're getting. There's nothing there. However, we do have a problem here that they're actually going out and doing walking and sports. Well, if you do that, you're going to get exercise, you're going to get healthy, you're going to change the study. So the Hawthorne effect due to sports and walking is what's screwing everything up here, which they shouldn't do. That's the worst one because you can't really test that out with placebo, basically, or placebo or blinding. Okay, so I changed a little bit for the next one. Subjects are given unmarked pill bottles created by doctors this time. Okay, so they didn't pick them out. The bottles contain either vitamins or water pills, so a placebo. Subjects are not normally vitamin consumers. The doctors monitor subjects and conduct surveys to determine if there are any changes in their energy levels. All subjects report having higher energy levels. So the control group is the people who got the water pills, right? So if you don't get it, what happens? Versus the treatment group is you got the vitamins, right? So the placebo, we did get one this time, was the water, right? And, well, the doctor is the one giving them out. As the subject, you don't know what you're getting, but the doctor does. So that's just a regular old blind study, not a double blind, because the doctor knows. But the problem is every single person is saying they have high energy levels. That's obviously not the case. That's definitely a placebo effect because it didn't happen. They're just reporting that it happened. So that's not good. Okay, so let's say we change the study slightly. So in this case, now it's given by a third-party pharmacist. The bottles contain either vitamins or water pills. The subjects are not normally vitamin consumers. The doctors monitor subjects and conduct surveys to determine if they can ascertain vitamin group from the water group. Okay, so the control group, right, still get water pills, and the treatment group still gets vitamins. And again, these are two different groups of people. Unlike the first time, it's the same group of people, just used twice, correct? Right, so it's one group of people, two groups of people, and then the other one with diabetes is, I guess you'd call it four groups of people because it's two, broken up there by diabetes or not. Placebo, yeah, they're getting the water pills again. Those are still a thing. But this time, the doctor also doesn't know. He's trying to figure out, or she's trying to figure out, who is actually being treated or not. And it doesn't really say any deceiving effects here. So don't read into anything. If I don't put something in my problems, don't assume that, you know, that there is something for one of these things, basically. If it's not directly stated there, don't worry about it. Okay? Okay, so again, don't worry about things that aren't directly stated. Don't try to make up stuff. And if we're doing a question where there are, you know, 3 options, right? There's going to be 3 questions with no, there's not going to be 2 prospectives, basically. If I ask you a question about something else where there's 5 options, it's going to be 5 questions and there'd be no repeats, basically. Okay? All right, that is the end of section 4.